Okay, so we're looking at another type of distribution, and this is called hypergeometric. And what it's to do with is sampling without replacement. So when we were selecting with replacement, we were getting events, and we described them as binomial. But when we don't have replacement, we call them hypergeometric. So just copy that down, and when you're ready, come across. Okay, so the number of type A in a distribution can assume normal values like 0, 1 and 2. These are called the hypergeometric variables, and the probability distribution that we get is called a hypergeometric distribution. So that sounds a bit random, but just copy it down. We'll have a look at some examples when you're ready. Okay, so we've got the size of the population is n. The number of type A, you're talking about two different things that can happen. So the number of type A is D, so the proportion of type A is D over N, okay, proportion of type A. The type B, because you've only got two types, the difference is N minus D, and this would be the proportion of B is N minus D over M. So when we get to examples, it'll make more sense. So what we've got is this formula for probability that the random variable takes some value. We need to know how many of type A there are, and we're going to take values of X, and then how many of type B, and we need to know how many we don't need of type A. And because we're talking about probability questions, we're going to divide by the unrestricted case. So when we have a look at a table, again, it should make more sense. Copy that down, come across. Okay, so we've got a committee of 5 is to be taken from 9 people. We've got 3 males and 6 females, and we can do a distribution for the number of males on the committee. So for instance, the number of males can take values 0, 1, 2 and 3, because we've only got 3 males, so we can take from 0 to 3. So the number of ways of taking 0 males from 3 on your calculator is 1, and then 3, then 3, then 1. So they're the different ways of taking 1 or 2 or 3 or none from your male population. So the number of people who are female are 6, and the committee has 5 people. So if we've got no males, we've got 5 females. If we've got 1 male, we've got 4 females. If we've got 2 males, we've got 3 females, etc. Okay, so then we use our calculator. Okay, turn my calculator on. 6C, calculator 6. Where's my C? Done the P. Sorry guys. 6C5 equals 6. 6C4 equals 15. 6C3 equals 20. 6C2 I think is back to a 15 again. Okay, so the unrestricted case is over here because that's what we're going to divide by. So we've got 9 people and we've got 5 people to go on the committee. So the unrestricted case is 126. So if you look at the previous formula, we're going to take the number of ways of one and the number of ways of the other, and then divide by the unrestricted. So we're going to have 1 times 6 is 6, and then divide by 126. 3 times 5 is 15 over 126. 3 times 20 is 60 over 126, and 1 times 15 is 15 over 126. Now all of these numbers could be cancelled down, but I'm just going to leave them like that for this purpose. Okay, so copy that, and when you're ready, come across. Okay, so we'll look at another example. We've got 15 solar cells and 5 are defective. Okay, so that means, so we're going to be looking at a distribution of the number of defective cells. So we've got 5 defectives, so we can take values 0, 1, 2, 3, 4. We can only take 4 because the sample size is only 4. So there are 5, but we don't need to worry about 5 because the sample is only 4. Okay, so we've got 5 defectives and we've got 10 normals. Okay, so in the first one, we're going to do 5C0, and then this will be 10C4, because if we've got no defectives we must have 4 normals. So in my table I've got x is the number of defectives and 4 minus x is the number of normals. Why 4? Because we're taking a sample of 4. Okay. Now the unrestricted case is 15 cells and we're taking a sample of 4, so the unrestricted case is 1365. So at the moment I'm just going to write up, so 5C1, 5C2, 5C3, and then this will be 10C3, 10C2, and 10C1. Okay. Oh, I've got not got my last line. Okay. So we use our calculator. So this is 1, 5, 10, 10, 5, and then 10C4 is 210, 10C3 is 120, 10C2 is 45, 10C1 is 10, 10C0 is 1. So the probability of x equals x. Okay, so we've got 1 times 210 is 210 divided by the unrestricted case. 5 times 120 equals 600 over 1365. 10 times 45 is 450. 10 times 10 is 100. And 5 times 1 is 5. Now again, all of these can be simplified down, perhaps, or to decimals, and you would be expected to do that, but for this purpose we'll just leave it like that. Okay, so that's example 2. Let's come across. Okay, so we've got one more example to do, and in this particular case we're going to sort of do the question backwards. This is actually question 23 from one of the exercises you're going to be doing, question 23 from Further Maths Macmillan. Okay, it's only on the worksheets anyway. So what we've got is, we know the sample size is 7. The largest what we're taking from is 7. The sample we're taking is 3. But we don't know how many defectives we've got. So this, when I did this, I just did it as a trial and error type approach. Okay, so we know that x is 1. So what we're trying to do is work out how many defectives there are. So if there was 1 defective, it'd be 1C1 times 6C2. Okay, we're taking a sample of 3. So 1 plus 2 is 3. The unrestricted case is going to be 7C3 is 35. Okay, so that's what we're going to divide by. And when you do those calculations, that number times that, you get 15 over 35, and that's not the right answer. So next one, you still got 1 defective, but now we'll move it to, we don't know how many defectives, so we say it's 2, and this time it would be by 5C2. And when you do that, you get 20 over 35, and that equals 4/7, and that's the right answer. But again, you could have just kept going, 3C1 times 4C2, and that gave 18 over 35, and that's not right. Again, we've already got the answer, but I'm just sort of showing you that there were other possibilities, but the one that worked was that one, which had 2 defectives. Okay, so there may be an easier way, but I just did it as a trial and error method. Okay, copy that, come across. So there's 2 worksheets I'll have on Moodle, and again, you don't have to do all of them. If you're going to restrict your time, I would do that one as my first choice. So on the thing, I'll call this worksheet 1 when I save it, and I'll call this one worksheet 2, which you can save up as well. Okay, right out, that's it, thanks.